While NASA's space websites flicker offline and Earth's telescopes get blinded by the sun, a confirmed interstellar intruder, 3 IATLAS, blazes past Mars at a wild 30 million kilometers away. It's the ultimate cosmic twist. Just as this strange, glowing emerald traveler hits its closest approach, America's science feeds suddenly go dark. Only the Mars orbiters from Europe, China, and the UAE can catch this once-in-a-lifetime show, snapping crystal-clear shots and gathering data. Earth can't even glimpse. Every second counts before 3 IATLAS vanishes forever into the dark. But the real question is, what secrets will Mars's robotic eyes expose about this cosmic rebel that breaks every comet rule in the book? The countdown to this alien encounter is already on. On October 3, 2025, the solar system's setup locks Earth completely out of the game. 3 IATLAS races past Mars at just 0.2 astronomical units, roughly 30 million kilometers away, while the Sun stands right between us and the comet, blocking every Earth-based view. The elongation angle, that slim slice of sky separating the Sun from 3 IATLAS, shrinks to under 10 degrees, a total no-go zone. Ground observatories won't even try. They can't risk melting their optics or frying their sensors. For nearly 6 long weeks, from late September through early November, Earth is in a blackout while the comet hides deep in the Sun's glare. But Mars gets the front row seat of the century. Its orbit sits 40 degrees offset, giving it a wide, safe view of the show. The Sun-Atlas-Mars angle stretches over 50 degrees, meaning Mars orbiters and rovers have a crystal-clear shot. While Earth's eyes are blinded, the red planet's machines will see it all. Every flash, flare, and mystery move 3 IATLAS makes. For a brief moment in time, Mars becomes the solar system's only watchtower. Every lost hour means a permanent hole in history. The window to observe 3 IATLAS isn't measured in days. It's just a few tight orbits before the comet shoots off and the geometry shifts again. Mission teams, usually planning months ahead, are now forced to improvise fast. Routine schedules are tossed aside for emergency retargeting. Cameras built to scan Martian valleys or sample thin air now aim deep into space, hunting any flash or flare before it's gone forever. The pressure is insane. Each orbit, each downlink could be the last shot to capture something new. Across Mars, multiple spacecraft jump into action, each tuned to a different slice of the spectrum. ESA's Mars Express and the ExoMars Trace Gas Orbiter grab high-speed observation slots for the week of October 3rd. Mars Express fires up its stereo camera and Omega spectrometer to snap detailed color and chemical maps, while the Trace Gas Orbiter's Nomad and ACS spectrometers split the comet's light into thousands of wavelengths, searching for rare gases and mystery molecules. Every move is risky. Each pivot must balance against heat limits and safety rules. Quick-look data might drop within days, but full results take months of careful checks. Meanwhile, the UAE's Hope orbiter joins the chase, bringing its own fresh angle on this once-in-a-lifetime cosmic visitor. The UAE's Hope orbiter jumps in with its EXI camera and EMUS ultraviolet spectrometer, normally used for studying Mars's atmosphere, but now ready to chase a glowing comet across the sky. Its global orbit and flexible aim make it perfect for wide-field imaging and ultraviolet spectra. If the team greenlights a rapid response, Hope could deliver early results within a week, just like it did during past comet and solar storm events. China's Tianwen-1, armed with high and medium-resolution imagers plus a mineral spectrometer, could add context shots and near-infrared data if retargeted. But official confirmation of its 3 IATLAS campaign hasn't dropped yet. Its data usually becomes public only after weeks or months through official releases or research papers. Meanwhile, NASA's Mars Reconnaissance Orbiter could turn its famous high-rise camera and CRISM spectrometer toward the comet. It's done it before with asteroids and comets, but off-nadir targeting needs pre-approved plans, and the current US government shutdown might delay public access. Still, the internal teams keep watch, protecting the spacecraft and Mars's environment. Even beyond Mars, ESA's JUICE spacecraft will try to catch 3 IATLAS during its outbound cruise in early November. The angle isn't great, and its tools, Janus, Magus, and UVS, are meant for faint, faraway worlds, so whatever it gets will be precious. But don't expect those results until early 2026. Together, this fleet forms a global web of eyes, each one adding a unique piece to the puzzle of this mysterious interstellar wanderer. The delayed data drops and cross-agency teamwork mean the story of three IATLAS will unfold in layers, each new data set adding another piece to the mystery. On October 2nd, NASA's Perseverance rover locked its gaze on the Martian sky for 9 straight minutes. Every frame from its right Mastcam Z came tagged with exact timestamps, filters, and orientation data. The sequence was supposed to be a routine sky survey, but then something wild appeared. A faint streak sliced across the star trails, too fast for a planet, too steady for a satellite. The team instantly went into calibration mode, correcting every raw frame for bad pixels, dark noise, and ghost reflections. Each artifact had to be hunted down before they could trust what they saw. Once cleaned up, the streak stood out clear, a faint but steady line cutting through the stars. Next came the astrometry check. Analysts pulled NASA's spice kernels to translate the rover's pointing data into sky coordinates, overlaying it with the predicted track of 3 IATLAS from JPL horizons. The streak's angle and speed? Nearly 400 arcseconds per second, a perfect match for the comet's path as seen from Jezero crater. Everything lined up, the direction, the velocity, the timing, but the team isn't jumping to conclusions yet. Coincidence isn't confirmation. False positives like cosmic rays or internal reflections can fool the eye, but this streak, it held steady through frame after frame, refusing to vanish. Image analysts run median filters and sigma clipping to erase every glitch or dust flicker. Each frame is checked for any hint of a flare that could expose a camera fault or Martian haze. Then comes photometry, and the results are stunning. The streak is faint but steady, its brightness matching exactly what a fast, diffuse comet coma should look like from Mars's distance. The light curve stays smooth, no wild spikes, no sudden dips. Analysts compare it against models of comet outbursts and sunlight reflections. Everything lines up perfectly. The final step, matching the streak's position to the predicted path of 3 IATLAS. The difference between the two? Just a few arcseconds, well within the margin of error. The data screams real, but the proof still hangs in limbo. With the US government shutdown, NASA's instrument leads are silent, their reviews on pause. Independent researchers like Simeon Schmo and Shi Maus post their own findings, but everyone's waiting for NASA's official call. The stakes couldn't be higher. If real, this would mark the first ever direct detection of an interstellar object from the surface of another planet. But science moves slow. Every step of calibration, astrometry, and photometry must survive intense scrutiny before it's accepted. For now, the space community holds its breath. The streak remains, etched across 9 minutes of Martian sky, a mystery glowing on the edge of history. Meanwhile, back on Earth, the last clear photo of 3 IATLAS came from a lone observatory in Namibia on September 25th. Just hours before the comet vanished behind the sun, it captured a brilliant emerald coma stretching nearly 700,000 kilometers wide, almost twice the distance from Earth to the Moon. The comet's core glowed bright green, unlike almost anything seen in our solar system. That eerie color came from sunlight scattering through clouds of diatomic carbon and exotic gases, creating a glow that looked almost unreal. But the shape was even stranger. 3 IATLAS didn't have a normal dust tail pointing away from the sun. Instead, it showed a rare sunward anti-tail, a wedge of debris aimed toward the sun. This bizarre fan-shaped feature, sculpted by heavy, slow-moving dust grains and the comet's weird interstellar path, gave it an otherworldly look. Faint arcs and ripples spread outward from its core, hinting at bursts of material ejected in waves rather than a smooth, steady flow. Later images from September 27th and October 2nd, though dimmed by glare, confirmed it. Atlas held its shape even as it faded, refusing to blur or stretch like ordinary comets. Frame after frame, the message was clear. This was no typical comet. It moved with its own rhythm, as if bound by alien physics. These final Earth-based snapshots, taken before our planet went blind to the event, became the baseline for everything Mars will see next. And the numbers? They're wild. Most long-period comets crawl into the solar system at 20 to 30 kilometers per second, but this one, it never slows down. 3IATLAS tears past Mars at nearly 60 kilometers per second, and by the time it swings through perihelion in late October, models predict it'll hit a staggering 68 kilometers per second. That speed leaves even the fastest comets in the dust. 3IATLAS is moving like nothing we've seen before, and its trajectory is just as weird. Instead of diving in from some random high angle, it glides almost perfectly along the ecliptic plane, only a few degrees off the path of the planets. For a true interstellar traveler, that's almost unheard of. Then comes the size shocker. Based on its brightness and coma models, scientists estimate a nucleus at least 5 kilometers wide, maybe even larger, putting it among the biggest interstellar objects ever recorded. That's on par with 2I/Borisov, and it completely dwarfs Oumuamua. But the coma, oh, that's where things really get wild. Instead of a long tail blowing away from the sun, Atlas wears a massive layered envelope, like rings inside a glowing cloud. Polarization readings reveal concentric shells, each reflecting light differently. No long dust tail, just a structured, mysterious green shroud powered by diatomic carbon that barely changes even under intense solar heat, or a coronal mass ejection blast. Every number, speed, tilt, size, and shape breaks the rules of comet physics. For modelers, this thing is chaos wrapped in math. On September 25th, that chaos faced its biggest test yet. A coronal mass ejection fired straight from the sun, right into the path of 3IATLAS. When a coronal mass ejection blasted out of the sun, forecasters braced for chaos. These solar storms usually rip comets apart, stripping ions, kicking up gas, and reshaping tails in hours. Scientists expected 3IATLAS to flare, twist, or explode into new patterns under the surge of charged plasma and magnetic shock. But what actually happened? Almost nothing. As the CME washed over it, Mars orbiters and ground telescopes saw barely a change. The bright green halo stayed sharp, the anti-tail held its perfect wedge, and the outer layers didn't expand or break apart at all. No ion tail, no flare-up, not even a shimmer of turbulence, just eerie calm in the storm. For plasma physicists, this was pure confusion. The comet should have reacted, but it didn't. Maybe its chemistry is different, maybe its structure is tougher than anything in the solar system. Whatever's inside it, it shrugs off solar fury like it's nothing. Now researchers are digging deep into Mars orbiter plasma data and high-speed spectra, searching for any hidden trace of that solar blast. Somewhere in that telemetry could be the comet's secret, a clue to what makes 3IATLAS so resilient, so alien, and so unlike anything we've ever seen before. 3IATLAS slices through the solar system on a hyperbolic path, unbound, unstoppable, and never coming back. That alone confirms it as an interstellar visitor, joining the elite ranks of only two before it, Oumuamua and 2I/Borisov. But the real challenge isn't proving where it came from, it's figuring out what it really is. Some scientists call it an interstellar comet, pointing to its glowing green coma, gas jets, and layered envelope. Others push back. No classic dust tail, an odd anti-tail, and a velocity that feels almost mechanical. The argument runs deeper than names. It's about proof. Every bold claim needs data that can survive the next round of scrutiny. The ghost of Oumuamua's hype still lingers. Wild theories spread fast, but only the numbers lasted. With 3IATLAS, the rule is simple. Test everything. Every strange glow, every shell, every steady pattern has to earn its place in the record. No one's claiming it's engineered, but until the evidence demands that leap, all we know for sure is this: it's from beyond our sun, and it's rewriting what we thought we knew about cosmic visitors. For those watching this mystery unfold, the action starts in public data portals, the ESA Planetary Science Archive, the Emirates Mars Ultraviolet Data Center, and the UAE Hope Mission's open access site. That's where new spectra, raw images, and fresh alerts will drop, each one another clue in the story of the strangest traveler ever to cross our sky. The ExoMars Trace Gas Orbiter and Mars Express are set to drop their first results soon, likely FITS files and quick JPEG previews for early analysis. Independent forums like the Minor Planet mailing list and the Comet Observation database will be buzzing. flagging every new streak or flare the moment it appears. Verification comes in layers. When someone spots a possible outburst, analysts cross-check it with predictions from JPL Horizons, or IMCCE, hunting for matching detections across Mars orbiters, amateur observatories, and even solar satellites. Community scientists often post comparison stacks, brightness plots, and motion fits within hours, especially when official channels lag behind or data is stuck under embargo. To track 3IATLAS as it nears perihelion, watchers will study each new image for shifting shapes, new shells, bright arcs, or that eerie anti-tail lighting up again. The real science lies in the raw data, not the polished releases. Comparing time-stamped images across missions and wavelengths is how the truth emerges. In this kind of event, transparency, teamwork, and open data are everything. Because in deep space, even the smallest detail can rewrite the story. On October 3, 2025, 3IATLAS swept just 30 million kilometers past Mars, while Earth's telescopes sat blind, blocked by the sun and a US government shutdown. In that blackout, Mars orbiters from ESA, the UAE, China, and NASA became the only eyes on this interstellar visitor, capturing data no one on Earth could see. Early images showed a glowing green coma over 700,000 kilometers wide and a wild speed near 60 kilometers per second. Yet the big mysteries remain: the comet's true makeup, the strange layered coma, and the total lack of a normal dust tail. Even after being blasted by a solar storm, it barely flinched. No bright flare, no dramatic change. As international teams analyze the mountain of data, the puzzle deepens. 3IATLAS is confirmed to be from beyond our solar system, but it keeps breaking every rule in the book. Until new results drop, this mystery stays wide open, proof that even with all our tech, space still holds secrets that leave us speechless. Don't forget to subscribe, like, share, and drop a comment below if you're following the saga of 3IATLAS.